So, title of the talk is Beyond Operational Intelligence, focused on using security analytics. A lot of what I'm going to talk about is, can be reproduced in any platform. It's more about the workflow in this session, as opposed to last year. I talked a lot about math. So if you want to know the math part, you can actually reference all my slides from the previous 2 years. So because we have lawyers and we're a publicly traded company, they make us put this in here. So don't go buy or sell securities based on anything I say or mention in this talk. So my name is Anthony Tellez. I am a staff data scientist at Splunk. Was previously a contractor for a geospatial intelligence agency in the US. My primary specializations are cryptography and red team. That's a lot of my focus before I moved into the data science area. As a data scientist, I'm focused mostly on security and fraud analytics, so trying to help customers and people discern, like, in this massive amount of data, who are the bad guys and who are the fraudsters that are causing their businesses to lose money. And then the other part of that is data visualization, right? Most people don't want to consume data in log format or in rows and tables, right? People like pretty pictures. It helps tell a compelling narrative, so data visualization is a really good way to help people understand complex topics. I'm also responsible for the TA for SuriCata, which is used to onboard or bring data into the Splunk platform. So if you have issues with it, I'm the person that you need to make pull requests or complain to. And then my role is global, so I'm on our global team, and I spend about 80% of my time on an airplane, mostly Asia Pacific and North America. So agenda. So we're going to talk a little bit about Splunk's and Phantom's capabilities, as well as the machine learning toolkit capabilities. And then we're actually going to use the incident response hierarchy as a needs for incident response hierarchy of needs as a guide to security analytics. And then we'll have some time for QA. So Splunk is a platform. We ingest data, logs, raw data, network data, right, into the platform. People create insights based off of that. It's no different than many other log platforms. The idea behind it, though, is you take that data and you build insights on it for many different types of personas. Typically, your security journey kind of starts with ad hoc search, right? I'm bringing data in from SuriCata, from Bro, from all kinds of different data sources, and I'm just trying to find the needle in the haystack. I'm trying to identify what are the problems that I see within my enterprise. And eventually you get a little bit tired of grepping through logs and doing ad hoc search, and you come up with statistical analysis. And eventually you get tired of tables and charts and move to visualization techniques to try and find what are the things that within this mess of data are valuable to me or insightful to my end user. And then lastly, we get to aggregation, right? We're correlating across multiple data sets, or we're using machine learning to elevate things out of the noise. So we have too many notable events, we have too many things that are alerts, and we try to take all that massive data and say, if we run an algorithm on this data, what are the things that are similar to each other? And can I address all of those things by just solving one problem, right? Identifying the root cause. So where Splunk kind of plays in this space is we utilize machine learning as part of our data pipeline. So instead of doing machine learning on the edge, we do it after the data has been ingested. We build our models, and then we apply our model at time of ingest. So data streaming in, whether that be DNS queries or proxy traffic, and then we apply a model to that traffic to classify it as, is this benign or is this ransomware? And then we can respond to that using an adaptive response action, such as any of our partners listed here, or utilizing Phantom playbooks to gain additional context. So I'll talk 2 more product slides. Promise it's not all product slide. So the machine learning toolkit is actually our open source version of machine learning. So we've introduced Python for scientific computing into the platform. So any of the algorithms that ship with that, you can actually utilize or build your own custom algorithms. So this is our way of open sourcing machine learning to our customers. We've updated to the most recent version of Python for scientific computing as of October. We also added Spark support, so now customers who have their own Spark stacks can stream data from Splunk to Spark to do massive computations and then return that data back to Splunk. And we also introduced a GitHub community. So a lot of customers and Splunkers are writing their own custom algorithms and then they're kind of sitting on them. We've introduced a community now that people can actually share those algorithms and do unit tests on them. That way, we can enhance the library that's available for the multiple security and fraud and IT use cases. And then lastly, we built a bridge to TensorFlow. So this was a huge ask by numerous people, like when is Splunk going to be able to leverage TensorFlow? So we've now introduced a methodology or a bridge to TensorFlow where you can now leverage GPUs as part of this machine learning journey. So that was the last slide. Okay, so let's talk about data science. So this data comes from Crowdflower, which is a popular machine learning platform where people kind of bid on different projects. And they did a survey of these data scientists and asked them, how much time do you spend doing various tasks? 80% of data scientists' time is actually spent doing data preparation and data cleansing. Very little time is actually spent on selecting algorithms and doing feature engineering or data visualization. It's mostly done cleaning data and trying to find the right data set. So keep that in mind as you go through your security journey, right? If you're spending a lot of time doing data cleansing and changing rules in SuriCata, that's normal, right? That's part of your data journey. So how many people have actually seen this before, this triangle? Okay, so this is called the SOC hierarchy of needs. And so this maps very closely to the data science process that you follow, right? And the first part of this triangle, as any process or pyramid, builds on top of each other in order to mature your security posture and your journey. And so the first part of this is inventory, right? Like, what are you protecting? So when you deploy SuriCata and Splunk or Elk or any products in your environment, if you don't know what you're actually protecting, it's very difficult to understand like what your risk profile is. And when we talk about inventory, we're talking about assets, right? And those assets aren't just the hardware or the mobile devices. They're also people and the software, right? The middleware and all those different components that make up the enterprise. So being able to identify those key pieces of those key assets is important to understanding what data should you be collecting. So if you're going to go down a journey of a machine learning use case, having the right data, as I said, is where we spend 80% of our time. And if we are missing key logs like for badging or for web server logs or middleware logs, it becomes very difficult to build a model which can accurately describe an insider type of activity. Telemetry. So telemetry is very important to understanding visibility, right? So what are the metrics on those assets that exist in your enterprise? So one thing that I constantly see is, yes, we're collecting logs. Yes, we have all this data from SuriCata, from Bro, from whatever, right? And we can't actually identify what those IP addresses are in the enterprise, even some of the internal IP addresses. Maybe some people know because of various VLANs that they manage. They know that these are domain controllers or DNS servers or proxy servers. But being able to accurately describe what those devices are, and being able to assign priority and understanding the metrics around the different protocols that exist within your network are important, right? So some of the things that I call out here are SuriCata, DNS, and HTTP, right? Easy event types that tell you this is the HTTP traffic that we see in the network. This is the DNS traffic that we see in the network. And these are just pure statistical and contextual analytics that you would build on your journey to understand what is actually happening in my environment. Are these traffic profiles important to my overall security posture and or identifying whether a particular server is exhibiting something that's anomalous? Detection. So how do we detect unauthorized activity? So in SuriCata, this is a little bit easy, right? We use signature-based alerting to classify network and authentication behaviors. So if we see SSH connections, we have a SSH log, for example. We can also use the alert log. If we see certain signature types or indicators of compromise, it alerts us to say, hey, we think we see something that looks like unauthorized activity. And then we can use statistical analysis to then determine, are these false positives or are they noisy alerts and we need to adjust them accordingly? We can also determine the effectiveness of our rules, right? If there's too many weird type of user agent rules that are popping up, that tends to give us a lot of noise. And now we're having to sift through that noise to identify what are the actual alerts that are important to us. Triage. So how do you classify these, right? So now you're getting tons of alerts from SuriCata. How do you use statistics or your investigatory process to determine what was real and what was not real? So one way of doing this is frequency counts, right? You can look at the frequency that a rule fires or a certain behavior occurs within the enterprise and use it to, again, identify problematic and noisy rules, but you can also correlate that with other rules. So using two pieces of data to identify whether something is actually worth investigating. So for example, we can assign priority to those assets, right? If we did our due diligence in the telemetry stage, we should know whether seeing software installs or IIS type of calls coming from a domain controller is problematic. So again, these all build on top of each other and you use them to begin to build a data set for machine learning. And it also helps you keep your focus, right? I mean, that's the point of the cat picture, right? Is he's focused on somebody else while the actual bad guy is making his move. So threats. Who are your adversaries and what are their capabilities? Depending on your enterprises, these could be any of these on the list or not, absent from this list, right? If you're working for a government agency or a bank, these could be geopolitical, they could be cyber criminals, they could be competition, right, or third-party contractors who have a interest in seeing your enterprise fail, or taking important information from your enterprise to profit from. Or they could just be doing it for the lulz, right? Script kiddies and hacktivists who want to deface your websites and have a little bit of fun at your expense. So being able to understand the motivations behind your attackers helps you create behavioral patterns, right? If somebody is purely attacking you because you have a very nice AWS cluster that's running GPUs and they want to mine Bitcoin on it, you know what they're after, which is monetary concerns. So you need to protect those assets in a way or develop models that are focused in on those types of traffic patterns or those types of behaviors on that server cluster. Another thing that a lot of people miss is the use of honeypots. Honeypots are a really easy way to get free data and free threat intelligence that is more accurate than even sometimes the paid stuff that's out there, primarily because it's real time. You're able to actually see what the attackers are using And there's tons of honeypots out there that leverage Suricata. So ThreatStream, for example, has the modern HoneyNet framework. That's what I utilize. And I can deploy Suricata with Amen and Cori and a bunch of other different products or softwares to cross-correlate. Not only did I see an SSH connection, but I also see what they tried to do within the environment that I gave them. Behaviors, right? So this is where we start getting into the actual machine learning part. So how do you detect an adversary? So north-south traffic, when it comes to machine learning, is pretty straightforward, right? You're looking for CNC, you're looking for data exfil. These can be achieved through statistical means or through textual means. So if I look at a DNS query, looking at the Suricata HTTP logs or the DNS logs, I can use bigrams and trigram pairs, or the entropy of a domain, which is the randomness of that domain, to then classify whether or not it's bad, whether it looks like DGA. East-west analytics, on the other hand, is going to be behavioral patterns. I'm building baselines for my user community or for my enterprise of the different entities or assets that exist to understand when is somebody doing something that's outside their normal behavior. So some of the logs you might look at are the flow logs, DHCP logs, DNS logs. Right? You can infer a lot of different protocols just based on the desk port and what types of traffic is going on when you're looking at the flow log. The other thing that you might look at is a one-to-many type of connection or a many-many connection, right? And if you know what type of asset you're monitoring because you've built upwards on your pyramid, you should know whether it's normal for an asset that is a DNS server or an exchange server or a domain controller to behave in a certain way and send traffic externally to a third party. Hunting, again, so how do you find enemies that are already embedded? Again, machine learning. So we can utilize anomaly detection, and anomaly detection is kind of a misnomer. So there's two different ways of doing anomaly detection. There is statistical, which is somebody falls outside of an expected threshold using standard deviation or IQR or median absolute standard deviation, or we could use clustering. Right? K-means clustering, so like K-nearest neighbors. And if you've built your inventory list in such a way that you know these are domain controllers and these are IIS servers or SQL servers, you can use that labeled data, but you can also do unsupervised machine learning to say, here is the network flow of everything in my environment, and then when I apply labels to them, do they all behave similarly? Are my IIS servers behaving the same way, or do I have one that's behaving differently from its peer group, or it's acting like a domain controller, and vice versa? The other thing is we can look at expected traffic patterns. So Chevy-Chev's inequality is used typically for non-normal data. A lot of people always ask me, how do I know my data is normal, right? So if your data is not a bell curve, then it's not normal. And typically IT data is not normal. So we can use Chevy-Chev's inequality to forecast what the expected range is for traffic for a particular device or for a group of entities. And when we forecast and when they don't match our forecast, they then are considered an anomaly. So if we forecast them with a 95% confidence interval that it's within this range of traffic and they fall outside that, we would consider that an anomaly and worth investigating. And then the last thing that I always talk about, because it's still pertinent, is a producer-consumer ratio, which is a very simple client-server relationship. So how are these two behaving? How is the client and server behaving in relationship to each other with packet sends and receives? So tracking. So how do you observe an adversary in real time? Obviously, visualization is key here, as well as machine learning. So building models is key to this, right? Having a model that incorporates the correct features, some of the things I talked about, like for ransomware, looking at the Shannon entropy of the domains, character-based features of the domains, like how long is the domain, or how many consonants or how many numbers are in the domain, bigram and trigram pairs of the domain. So I could come up with an infinite number of features that might or are correlated to ransomware. And once I've built my model, I can apply it in real time. And when I apply it in real time, I want to consume that model, not as an alert, but possibly as a visualization. So I can understand who's attacking me and where they're coming from, maybe where they're pivoting to within my network. Botnet is very similar, right? Looking at SuriCata flow logs, I can look at the producer-consumer ratio I mentioned before, total packet length, and bytes sent or bytes received. And then lateral movement, I can do something similar. I can build a model that looks at what does a successful SSH authentication look like by combining not just by combining the flow data with the SSH authentication logs. So the SSH authentication logs tell me I had a successful public key authentication from IP blank at this time. And I can correlate that with the SuriCata log to then start to build a data set that tells me what is the packet range for a successful authentication. And as a human, I'm not able to actually look at a SuriCata flow log and say, that was a successful authentication because the packet range was between this and that, right? I could build a model that can do that though. And I can then classify that, I can then use that model to classify large amounts of traffic I haven't seen and build I can then apply that model and build a visualization that tells me who authenticated to what server based on this model, and did they make multiple hops to other servers during the same time period. So countermeasures, right? Doing machine learning for fun isn't actually that fun, right? We do it because we want to disrupt, or we want to be able to act upon the intel that it provides to us. It's a weapon in our arsenal against cyber criminals. So using machine learning for detection is cool, right? It's the new hotness that everybody wants to do, but it's meaningless if you can't actually do anything with it, right? So being able to act upon those machine learning models is critical. So tying it to an automation tool, right? So this year we acquired Phantom. So Phantom is what's shown on the screen here, right? So I can take a machine learning model. The results of that model can be passed to Phantom, and Phantom can then go run a playbook to say, yeah, we're agreeing with the model. Let's remove that host from the network. Or Phantom can do additional actions like, let's get some additional context from that host and provide those indicators of compromise back to Splunk. And then I'm going to maybe update an additional model based on the context that's provided back from Phantom. No matter what you choose to do, you want a feedback loop as part of any machine learning solution that you build. You want to have some kind of automated capability that gets you additional contextual information around what the model detected, and a way to also remove that host from the network as quickly as possible. So some of the features that might return back if we're building a model around phishing or ransomware could be entropy of that was found on that, IP reputation, or whether it was a first time seen email domain, and add it to our list. So then when we retrain our model, we have a new domain that's accurately classified. So collaboration, right? So this is the last step on your security journey. And this is really about disruption, right? Just because you're secure doesn't mean everyone else is secure. And so if you can collaborate with trusted partners to disrupt a cyber campaign, that makes everyone else safer. And so the ability to take information from Splunk or from any system and push that back to the community is really important. There's a number of open source projects out there that are free and paid, right? So Threat Connect is one. There's Threat Exchange from Facebook. But SuriCata, when you turn on file info, gives you hashes. You can share those hashes with the community once you've done your investigation. The other part to this is this is a repeatable workflow. So all the workflow that you build within Splunk or in your data science platform, you want to be able to reproduce and be able to share those model files and share what are the important features to detecting that particular strain of ransomware or malware or lateral movement or whatever cyber campaign is targeting your enterprise.